everybody. Today, I come to talk about applicative in real life. So, I'm Jeremy Chassaing. I'm working at DH. This is a Accor tech hub company that is working in the hotel business. And you can follow me on Think Before Coding on Twitter and read my blog where I talk about all this domain-driven design, secure event sourcing, functional programming, and all that, all the cool buzzwords that you like. Who is fluent with functional programming here? Yes, okay, the rest is not. It's not a problem because we will not use the M word or thing like that. So what I will do is I will code, and I want to show you real world places where the use of applicative can simplify your life. We will start with a really simple example. That you can meet daily in your work, and then we will go with more complex usage, but where not using applicative can just become a nightmare. So you will see that the same concept apply every time, and I will not explain to you what an applicative is. You will just see it in action, and then based on the different example, you will catch why it's the same thing every time. Okay. So let's start now with just a usual thing is that often we need to parse some strings coming from the outside, and so we will just create a try int function that takes an input, okay? And what we'll do is that we'll try to parse it. So when I do a try parse like this with my input, the thing is that I get a Boolean, an integer value, which the Boolean tells me, whoops, I will just remove it. The Boolean tells me that it's succeeded or not, and the integer tells me what is the value if it's succeeded. Said like that, it's a bit difficult to use. So in F# we often have a type which is called option. And an option of t, so it's a generic type that can operate on different other value, and an option of t is either some t, like that, or none. So we can just write this way. We say we either have a t, in the case some, or we have no t, in the case none, okay? So let's just return that from our function. We can match the result with. So we have two cases. Yep, at the beginning of the talk, I'm always a bit nervous, so it's a bit harder to, but it will get more fluent as I type. Okay, so in the first case, I have true and a value v, and we will just return some v. And in the other case, we have false and no value, and we will return none. Great, perfect. So now that I am here, I can use it, try int, with a value like a string which is 42. I will just execute the code so that we can use it. Okay, and when I do this, I get there some 42. Yes, we have an int, it's a value. But if I try it with b42 like that, I get none, because it's not an integer, okay? Perfect. Now, let's say I have a simple function that takes an integer, like increment. Increment x is x plus 1, okay? So we have this. And now we want to use it on this value we get. But the problem is that sometimes we have a value and sometimes we have not. So what should I do in this case? Maybe I could do something like match try int. So we can do something like let try inc equal, and having an input which is an optional inc integer or x. And we will do something like, if we have some value v, we can just return that we have some value v plus 1. And if we have no value, we say we have no value, so no need to do that. But the problem is that as I have more functions, I will have to rewrite this version for options every time. Maybe we can do something smarter. Here, we can see that we have the inc function here and here. So maybe I could just write that. It's easier. And what if, instead of doing that, I say, no, actually, I will pass the function as a parameter and just apply it here. Here it was v, of course, excuse me. Up like that, okay? So now what I do is give me a function, and when I have a value, I will apply it and return it, okay? This small function now has a better name, which is map. So map can be applied to any function, okay? And you can see in gray there, the signature of the function. It says, it takes some things that change A to B, and when we have a function, an optional A, we will get a functional B, an optional B, okay? So if you have A, it will become a B, but we have a none, we will get none. Right, easy, cool. Right. Problem is that after that, I not always have one parameter function. Sometimes I have two parameter functions like add y and x, call that. Oh, so what could I do here? Because it will not work. I have two parameters. So if my two parameters are optional, like I have I will just use my map function with that. So map int to show you with a try int 42. Yup, here and here. And I can execute everything like that, and we will show that it works. So in this case, I have 43, some 43, which is the result expected, but if it's not an integer, I get none. Right, good, we have a map. This is once you have written this, you already understood the concept of functors, so it's good. Yeah, great. Let's continue. So now we have a two-parameter function add. What can we do? Maybe we can do the same kind of things with a map to thing. Let map to, and we get a function that takes two parameters. Okay. For now, I don't write more, but we will see. And we'll take an optional x and an optional y. And what should we do? We have those two things, and maybe they have value, maybe they have not. So if they have both values, it will be easy. In that case, we have an x on the left, and we have some y on the right. I can just say, in this case, I have the result of passing those two values to the function. So here, I can return the value. And in any other case, when there is none on one side, on the other, or both, so I will say any other case, I just return none. And here, the signature is also interesting because it says, yep, you can look at it in gray. It takes something that takes an A and a B and return a C. It takes an optional A and an optional B, and it will return an optional C. Perfect. So let's try it with our add function. We can do a map2 with add, and we have two parameters, try int, which will be 10, and another try int, which will be 32, and the result, yep, I didn't define the things. Okay, great, execute, and when I run it, I get some 42, which is actually the sum of both. But if the parsing fails on one side, I get none, which is exactly what I want, okay? And then we have still the same problem once we start to have a free parameters function, okay? So let's say I have a user, so type user equal, and the user has a first name, which is a string, and the last name, which is also a string. And the last one will be an age, which is an integer. And we will add this function that tests let not empty, which take an input and say that if the string is null or empty, we don't want it to propagate to the rest of the system, so we will return none, okay? And in the other case, else we will just return some of the input. So this function is taking a straight up input here. And in this case, so it takes a string and it will return an option string with a string that is not null or empty, okay? And now I want to build my user using a free parameter function. First name, last name, and age, and it will just build the user like that. First name equal fn, last name, which is Chassaing, equal to ln, and my age equal age. Great. So in this case, I have a function that can create a user that takes a string, and an integer. And the thing is that since I get my input from untrusted sources as strings, I want to use my function with something like try int for the age and not empty for the input string. How can I do that? The problem is that I have a map and a map2, but how could I go further than that? Should I add a map3, a map4, map5, map6, map7? Actually not. The interesting thing is that, so the first thing I can do is to try map on user with a first value, like not empty, of the name, John. Okay? So we'll try that to see what it gives. Yep. And look on the right, what we get. Oh, I will, to show you better, f equal. What I get is this. When I do that, I get an option of string arrow int arrow user. What is this strange thing? If you notice, actually, the signature of the function user, it says string arrow integer arrow users. Why all those arrows like that? Actually, if you look at the user function, there is something interesting, is that it expects a first name, okay? What if I just pass the first name? User John, like that. It tells me that actually the result of that is a function that waits a last name and an age to return me a user. So if I give a second the name, the last name, I get a function that waits for an age and that will return a user. If I provide the age, I get a user. Nice, okay? So when I did map user with my option that contains some John, actually it passed this value to the function. So now if the value is a sum, I get the function that waits for the rest. But if the value is none, I will get none. So I may have a function to which I can pass the other parameter or not. Let's use that. It's very interesting because now I can write this, I can use my map like that. Let's say I have my f. Okay, I can say map2. I will do something with that. On the left, I will have my function that waits for the rest, and here I will have the rest, the last name, not empty of dough. Okay. In map2, I provide a function that will use the value inside if both are present. Okay. So on the left, what will I get? I will get this function that waits for the last name to continue. So I will just call it, yeah, maybe f here was not a good, it's cont or something like that. It's a continuation. And here, I will call this function f, and the value on the right, I will call it x. And what will we do with that? It's really easy. I will just use the value, pass it to the function, and I will get something. Let's see what it is. This thing is actually an option of a function that waits for an age and return a user. So I can start again to give it to use map2 this way to apply so that I will finally have my user. So let's continue. Let count result equal, and we'll do another map2. I will have once again a function on the left and a value on the right. I just pass the value to the function, and I give it the other, and I put the try int of 42, and now I have an option of user, okay? So you've seen what we did. Each time we use map2 to, if we add a function because there were enough value before, I extract the function, I extract the value, and I pass the value to the function, and I get either a new function, either the last result. Written like that, it's not very practical, and since we already wrote 2 times the map2 with the function thing, we will just create a function that is called apply, and that takes an option of function on the left and a value option on the right, and just do that map2. We will pass on the left, so our function option and our value option, and what we do is we get the function out of the function option on the left, we get the value out of the option value on the right, and just apply. Okay? Now, written like that, it's a bit intricate and not very easy to read. So we'll just use those 2 frequent operators. This one is called map, and the other one is called apply. Okay? The interesting thing with operators is that they can be put between the arguments instead of in front. So with the bang mark like that, we will put the function on the left and the argument on the right. On the other one, we will have the resulting option of function on the left and the thing on the right. So we can rewrite it. So here, we can just say user map not empty like that. And actually, I can also here write apply like that, but apply will be actually using that. And if we continue, I will show you, we can write things like that, like saying user, and then, check. And the last one is this way. And like, okay? So this is my result. And I get an option of user. Okay. So let's just run it to check that it's working. And now, if I change, for example, the user provided no last name, none, great. Or the age is not an integer, none, great, okay? The thing is that we can continue like that. If we add another property here, we'll just add a new parameter to the function, and we can just apply again with another star like this and apply the parameter. So we can have as many map 3, 4, 5, 6 as we want because we can just apply the star, okay? So good thing here is that now that we have a user that is an option, we can actually use it to pass it to a function that use a user. And using map, it will work, okay? Or if you want a function that take 2 users and do something with them, and both users were on the options, you can just apply the map2 to them, and continue like that. So the good thing is that my user function here doesn't know about options, okay? And still, it can work on option just because of the small operation here. So I take a function that knows nothing about options, and now I have a function that takes options and return options. That's quite cool, because my testing is easier if I can test my user function without knowing about option and just changing this way, okay? So this is really interesting in parsing, and something we use a lot is another type which is called result. So I will just put most of that thing no, I will have to rewrite that. Okay, so this is our take on options. Okay, I will not write everything about results after that, but you will see the ID, and we will move to the next sample quickly. Check. I just try to. Yes. So a result is also generic, but of 2 things. of a success on an error, and it will say either OK of S. So when the function succeeds, it can return a result, and if everything went right, it will return OK with a value of type S, and if there is a problem, it will return an error of type E, OK? And here, you can quickly see that we can do exactly the same, like try int equal of input equal match. I take my integer, I try to parse it, it's my input, and in case it's OK with true, and the value v, I will return OKV. But in the case it's false, I have no value. And here I will say something like error. This is not an int. Try to find better error message in your code, please. We can do the same thing for the not empty thing with the input, and say match if string is null or empty of input, then in that case error the string should not be empty, and other cases else I will just return my OK with the input, OK? And we can see that it will be really easy to do the same thing. We can create a map that takes a function and a result, an X result, and that will match the X result with OK, which will contain X, and we just say OK, and we pass X to F. In case we get an error, we just return it. You see the pattern? Really easy. For the map 2, it will be the same thing. I will take both. If they are both OK, I can pass the both value to the function. And once I have when I do that, I can return that it is OK with the result of the function. In case of error, I will take one error and return each, or take both errors and combine them to give the result. And we can do exactly what we did before. OK? I will take more time to explain, and we can define the same operators. I will take more time to explain another case that is quickly a nightmare when you don't use this kind of technique. So let's say we have some values that change in time. Okay, this is something that we have a lot in the hotel business, because all the hotels say that their price is this for this date to this date, and that there is this number of room left from this date to this date, and all that. And so to model that, we will create a type, which is called a series. And a series is simply, so a series is depending on a type for the time values. Okay, so here we will call it D. And the other one is the type of the values for each moment in time. So this series, I will write always have a values, and to always have a values, we will give an initial value here. So the series will start with a value t, and then be followed by a list of pair that contains a date and a value. Okay? Like that. So for instance, there is a simple function which is we can call always, and which is always x. Okay, a series is always x when its value is x, and it never changes after that. Okay, so here, for instance, always 0. Check, and yes, I didn't give it a type for the date. So here, maybe I can remove that, and it will be easier to show like that. Let's say it's always that time. No, an integer. Okay, so we have moment in time represented by integers. So here I have my series like that. Okay. I can get more complex series, like series that will say, okay, at the beginning it's 0, but on the 10th day the value is 5, and on the 12th day the value is 7, and then after 20 days it's back to 0. Okay, this is a way to say that. Perfect. Now, let's say that I have, again, my operation increment. I want all those values to be incremented by 1. How could I write that? I think you already feel that maybe map is a good idea to actually apply these increment things to this structure. This is what we will try to write. So we will write a map which take a function f that we will apply to the values, and we take our series x, so x's, okay? Actually, x's is a series, so we can just deconstruct it like that. We say it's a series, and the initial value is we'll call z, and the rest we will call x's like that, okay? So we have a function, and we have a series where the initial value is z, and the other things are x's. So the result will be a series also, and the initial value will be what? We have a value, we have a function, just pass it, like that. So the initial value is passing the initial value to the function. And for the rest, it's a bit, it's not very complicated. So in each part of the list, we have a date and a value x. So what we will return is the same date, because we don't want to change dates. We just want to change values, but with passing the value to the function, okay? And now, the magic happened, cool. We can call it map inc with our series that is here. I will call it x, like that. Great. When I call it with my value x, I get this series that instead of being 0, 5, 7, and 0 is 1, 6, 8, and 1. So now I can apply this function in time. So, for instance, you have a value that changes in time. You have a function that can act on this value, and now I can make this function apply in time. That's great, because I will not have to write this list transformation thing anymore. I can just use map, and automatically my function can be applied in time. Great. But the problem is, how will it behave when I have this add function? Yeah, I have, for instance, or a multiply function. For instance, I have a price and a quantity that both change in time, and I want to compute the total price of this quantity multiplied by this price, but both values change in time. Oh, that starts to be quite tricky problems. And the thing is that if I have to rewrite this logic of what is before, when it's the same value and all that all the time, it will be really complicated. So, for instance, we had x, which was a quantity, and we want to have a price, which will be like that, a series. So, just to illustrate, the price, initial price is 100, but on the seventh day, it's passed to 110, and then on the 10, it changed to actually 105, and then on the 17, it will be back to 100. Okay, so sometimes one is changing before the other, sometimes they change together, and then you have to produce a result based on that. Whoa, it gets a bit tricky. So let's try to fix this with, we'll make our map2 with two series. The first one will have x with as an initial value of xz, and it will also have xs values after that. And on the right, we also have a series, and the initial value will be yz, and the rest will be like that, okay? So what will the result be? Of course, the result will be a series. So let's write it. What is the initial value of this series? Let's just take the two initial values and pass them to the function. So I write f xz, yz, like that, and the rest, which, okay. It will be not that easy, but we'll write it anyway. Let's break loop, and we'll call this thing. So to do the computation, we need to remember the previous value, because each time we have a new value on one of the series, we will combine it with the previous value of the other series, except when they change at the same time. That's the last case we'll see. So let's take the previous value here, and the rest of the series like that. And we'll take the initial value for the y's like that, and the rest of the series like that. And what we do is that we will want to return a list. So let's write it. And we'll see what's at the head of both lists. So I take my list, and I say, if both lists are empty, like that, OK, I'm done. So I can just finish. If I still have some x's, my x is starting with x date and x value, OK, and then I have x rest, like that. And on the other side, it's over, so I can just say it's over. In that case, I have only two values. I have my xv, which is the new value, on my yz, which is the previous value with y. So I will return in my list, result list, for the date on x. I can just call my function with the new value on x, xv, and the previous value yz, like that. OK? And to continue, I can just call back the loop and return everything it will return, like that. And the new last value for x is actually xv, and the rest of the list is xr. And for y, I don't change anything, and I don't have anything anyway, so I can just do that. The other case, you will see it won't be very long after that. The other case is when y has value but not x. So it will be the same thing but reversed. So I have yv, and I have yr, like that, and I can just yield. So I take the date, I push both values to the function, so it will be xz and yv in this case, because I have a new value on y, and I can also return the rest like that with previous value in x, xz, previous values in x, and yv. This is the new value, and the rest of the thing. I hope you still follow me, but you will see the result shortly. The next thing is when both have a value. Oh, bad. Like that. In that case, I can... Actually, in that case, it's not very different, because if x is changing before y, OK, I have this case where x is changing before y. In that case, I'm exactly in the same situation as here, because I will actually use this value in x, but combine it with the previous value on y. So I just copy the code. Here is a then. And there is a case where the y is before the x. And in this case, this is exactly the same case than here. I want to show you how painful this code is, OK? This is intended. Yes. And the last case is when both change at the same time. And actually, it's quite easy, because I have xd, which is the same as yd, so I can choose any of this thing. This is either the x date, but they are equal. OK? So at the point in time d, xd, I can call with the two new values, so xv and yv. OK, and the last thing is to actually yield the rest, and the rest is xv xr and yv and yr. And this thing, I just have to call this thing here with all the initial values. So let loop xv xz xs yz ys, and fix this little misspelling. it's a Y, and normally it should just compile and work like that. Yes, great. And now I have a map too. So I have my two series, and I want to multiply them. So I will let total price quantity price, which is a function that doesn't know anything about time. Okay? And now how can I use it? I will just map 2 of total price with my initial quantity, my quantity, and my price. And now yeah, it was called P. Okay, perfect. Like that. I didn't define P, so I just have to define it there. Okay. And now when I do this, I get a series of int, which is my total price. Okay, so it made the multiplication at each moment in change. You've seen the difficulty to write this function, which actually is quite short. It's 20 lines of code. But now, the good thing is that I can take any function that doesn't know about time and make it know about time. So now that this code has been written once, I can use any function over things that change in time. Prior to the introduction of this map2 thing in the code, we had something that looked like that, and it was not F#, but it was C#, so it was something like 10 or 20 times longer than that in every function that was actually computing things on values that change in time. So you have very error-prone code that have to do all these mechanics every time on every value. Now I can just take any function. So let's write the apply function, let apply. And apply, it's always the same. I just take a series of function, and I take a series of value, and I make a map2 that on the left I pass this, and on the right this. And inside, I will get the function each time and the value each time, and I just pass it. OK. Let's define our small operators like map and apply, like that. And, yep. 1 to 2, this one? Oh, yeah, that's Y. Yeah, thank you, the math, to spot it. Yeah, great. It should fix it? No. OK, that's the hard part with, yes, it's the same problem here because I made a copy. Yes, great. Should be OK now. Great, check. And apply is now OK. And now we can do things like total price and use map with X and with P, and this will give the result. OK? And now you can use this to call any function that doesn't know about time you have. So you can write all your domains like if you do computation like that, and then apply it in time. Okay? This is a real complexity reduction once you just write this operation. Let me talk about a last case. So it was the case about series. Great. So you've seen the pattern now, where each time we write a map, and after that we write a map2, and then we write an apply. Okay? And we'll do this with something. I started a small Elasticsearch engine in the back, and I have a booking service here that enables me to actually get bookings in Elasticsearch. So I can give a reference, sample. I will give the reference of the booking like that, and then I can pass a list of properties like arrival, and departure. Yes, and whoops, I didn't. Yeah, here it's a semicolon, and here it's reference. Great. So when I call this service, it just gives me a document like that that contains the properties I requested. But you know, with this kind of service, the problem quickly is that you have a list of properties you need. You have functions that use those properties, and at some point they go out of sync. Okay, and then you have a bug that you will probably discover, hopefully in your integration test, mostly sometimes in production, and that's bad. So something that would really cool is that if we could have something like that, a type which would be a query, and that would contains a list of properties, which is a string set, and a get value thing that actually can take the result, which is a map of string. Okay, so it's just like a dictionary, and that will return a T. Right? If we can get that, after that we can write a let get booking function that will get a reference and a query, and it will call the booking service with the reference and the list of properties that is in the query. It's okay, and the result will be a map of string, so we can pass it to the query get value thing function, and it will return us a T. That would be nice. Okay. For instance, the easier way to create a query is to make a function that we will call prop, and that takes the name of the property, and that will just return a query that asks for a single property, which is actually the one named after the thing, and the get value will be a function. Then when we give it a map, it will just query the property inside the map. Perfect. So now I can say let arrival equal prop, and I have to avoid mistyping. I have a prop name already defined, IRL, but that's just the name of the property inside a value. And now when I do that, arrival, now I can use this arrival thing on my getBooking function. GetBooking. I use my sample reference booking reference, and I can pass my query, so for instance, arrival. And I get the arrival. Great. Okay. I cannot have a mismatch between the query and using it because it's all backed in the arrival thing. The thing is that here, arrival is a string. I would like to have a date. And the problem is that I have a function that is datetime dot parse. But the problem is that how can I could apply it to the result, but how can I apply it to a query? Yeah, this thing is called map. Map of query. And when we want to map a query, it's easy. How many properties we need? Actually, the same as the ones that were originally in the query. So, what's this sound? Okay. So I request the same properties, okay? But to get the value, it's just a bit different. What I do is that I will be provided a map with all the values. And actually, I can already use the query dot get value to extract my value from the map. So what I do is I just pass it to my function. And now you can see the signature. I have a function that takes an A and returns a B. You give me a query of A, I give you a query of B. That's what we want. So we can even create our fancy bang operator. Let bang equal map. And now I will redefine my arrival slightly differently, like datetime.parse bang. And now that's really cool because I have a query of that time. So let's use it. Choke, choke, and choke. Yes. I can also define departure the same way with departure there. Departure, and I can define with a E, and total price. And total price is a bit different because total price is the decimal, but I have a small function that is called decimal that actually converts a string to decimal. And I can just use it prop name and total price like that. So here I can also ask for total price like that. Problem is that now I have a function length that says this is the departure date, the arrival date. This is the date time, and I have a departure, which is also at that time, and it will return departure minus arrival, and it will take the day length of that and convert it to total days. Great. Or maybe days is enough. No, it's okay. Like that. Okay. The problem is that now I have a function of 2. So I just write the map 2 because it's really short and we get to the point in 2 minutes. Okay. So the map 2 is easy also because we will take a function, will take a query, an X query and a Y query like that. And we want to return what properties do we need? Actually, we need the properties of X and the properties of Y. For sets in F#, the plus is actually a union of the set, so it's cool. And now I can get the value, and this value, to get the value, I've been given a map. So I can get the value of X just by by saying that X is actually applying the X query, get value to the map. And I can also get the Y in the same way, but with the Y query. Like that. Now I have a X and a Y on the function. Easy, I can just pass it like that. Great. And you can see the signature. The signature says I have a function that takes an A and a B and returns a C, and you pass me a query of A and a query of B, and I give you a query of C. So now I can do a let. I will once again define, no, not yet. I can do length like that, which is equal to map2 of length on arrival and departure. And now the good thing is that my length is actually a query of float. Okay, and this query applied to my booking will just return me the length by asking for arrival and departure and doing the calculation on both. Great, like that, and I get 2 days. Then I can also create an apply thing, which will take a F query on the left and an X query on the right, and just to a map2 with always the same thing. So we have the F and the XQ, and actually on the left we will get an F, on the right we will get an X, and we will just pass the X. Great. So now we can define the star operator as being apply. And the cool thing is that now we can do something like let unit price equal. So we have departure, an arrival, departure, and on the total price, okay. And the calculation is simply to do length of arrival departure. That's our len, let len, and we just divide the total price by the length as a decimal. Great. This function, of course, doesn't know anything about queries, but now we can use it like let unit price equal, and I can just use unit price with my query that asks for arrival. I can use it, pass the second parameter as the query that returns the departure, and the final one is total price. And now, I execute it. Now I have a query. And you can see in the query that we are requesting an arrival and departure total price property and that we will use them. So let's just write the final line for this live coding session. I will require the unit price. And we get the result, OK? So the thing is now that you can compose all those things and get all the details you've written once to apply it to your more domain function, to access service, to move things in time. Actually, the applicative is this way to take functions that don't know about the underlying structures and just applying them on the structures. Thank you for following.
Thank you very much.
You can meet me on the Hacker booth there if you have more questions, or if you want to replay some part of it, because I know it was really fast. I like to talk in a 1.5x in general. Thank you.